matrices.
Okay, welcome to another episode of ALGEBRA with King Solomon and Nicole. Today, the topic we are treating is matrix. And when we talk of matrix, let's say it talks about a rectangular shape that is filled with AI, A1, 1, A1, and AN1, ANN. So basically, this is a matrix where n can be any number. So we have types of matrix. You have 2 by 1 matrix, 2 by 2 matrix. Why am I using 2 by something or something by something? Matrix basically comes in this form, m by n, where m stands for rows and n stands for columns. So like in that matrix, the first number here, 1, is standing for the row. That's why all of them here is started with 1. But the second number stands for the column. That is why this one is column 1, but this one is column n. And this one is row n, column 1. Row n, column n. So basically, this is all about matrix. So we can be given 2 by 3 matrix. When you are given 2 by 3 matrix, what does it mean? It means we have a matrix that has 2 rows but 3 columns. So we have A, B, C, making 1 row. D, E, F, making the second row. And the columns becomes 1, 2, 3. So this is a 2 by 3 matrix. Then we have 3 by 3 matrix. We have different types of matrix. Is that okay? So since we have different types of matrix, what we would like to move to is addition and subtraction of matrix. Addition and subtraction. Addition and subtraction. And before you can add and subtract matrices, you have to make sure that the matrices that you are going to add or subtract are identical. I mean, you can't have 3 by 3 matrix and add it to 2 by 2 matrix. It is not possible. So before you can add or subtract 2 matrices, you have to make sure that their dimensions are the same. So for example, if I have matrix A, which is 2, 1, 3, 4, 1, negative 2. This is a 2 by 3 matrix. And I have B, which is also given by 4, negative 3, negative 5, negative 1, 3, 2. So with these 2 matrices, when they ask me to find A plus B, the first thing I have to check is to check if their dimensions are the same. If the dimensions are not the same, I can't add these 2 matrices. So this is 2 rows, 3 columns. So this is 2 by 3. Let me check this one to 2 rows, 3 columns. So 2 by 3. So meaning their dimensions are the same. I can easily add and subtract. So in adding A plus B, you add them according to component. So this component will be added to this component. This component will be added to this component. So you add them component wise. So you are going to get 2 plus 4. Then 1 will be added to this. So you get 1 plus minus 3. 3 plus minus 5. Then 4 plus minus 1. Then you have 1 plus 3. Then you have 2 plus negative 2 plus 2. So after the addition, you see that you get, what is 2 plus 4? That's a 6. 1 plus minus 3, which is negative 2. 3 plus minus 5, which is also negative 2. And 4 plus negative 1 is 3. 1 plus 3 is 4. Negative 2 plus 2 is 0. So this is the sum of the two matrices. So like how I added them components, you can do subtraction, but that one you subtract it according to the component based on the question that you were given. So since I have done the addition and you've seen how it is done, you can try the subtraction on your own and comment your answer. Let's move on to multiplication. Properties of matrix addition. Properties of matrix addition. One of the properties of matrix addition is commutativity. It exhibits commutative property. It means when you add the matrix A to matrix B, it's the same as adding matrix B to matrix A. That is for addition. When you add A to B, it's the same as adding B to A. And it also exhibits associativity. If you add A to B and the result you add it to C, it's the same as adding A to B plus C. And also the last one, if you add A to a null matrix or zero matrix, it's the same as adding 0 to matrix A, and the resultant is going to be A. So these are the properties of matrix addition. Now let's come to multiplication of matrix by a scalar. Multiplication of matrix by a scalar. For example, if you have matrix A and you are multiplying matrix A by a scalar K, K is going to multiply each of the individual components of A. So let's take A to B. Let's say A is equal to A, B, C, E, F, G, I, J. So this is our matrix A. So if you want to multiply this matrix A with a scalar K, we are going to get K, which is going to multiply A, B, C, E, F, G, H, I, J. So K multiplies A, get KA or AK. Multiplication is commutative, so any of them is okay. Get KB, KT, KE, KF, KG, KH, KI, then KJ. This is how we multiply a matrix with a scalar. So we are done with addition and subtraction of matrices, properties of matrix addition, multiplication of matrix by a scalar. The next thing to talk about is matrix multiplication, multiplying matrix by another matrix. Okay, so multiplication of matrices. So before you can multiply two matrices, let's say A times B, before you can multiply, or the multiplication of A and B can be possible. If A is having dimension Mn or MP, and B is also having dimension maybe Q by R, this matrix multiplication will be possible only when the number of columns in A or in the first matrix is equal to the number of rows in the second matrix. So if P is equal to Q, that is the only when you can multiply these two matrices. So sum of matrices that you can multiply is when you have two identical matrices, maybe 2 by 2 or 3 by 3, 4 by 4. That one is easy to multiply them. But if it is not a square matrix of the same dimension that you want to multiply, make sure that the A that you are going to use to multiply the B, its number of columns is equal to the number of rows of the second matrix. So let's take an example. If you have 2, 1, 3, 4 as A, and you have B as 2, -1, 3, -2. So example like this is 2 by 2. This is also 2 by 2. So you can see these two and these two are the same. So you can easily multiply these two matrices. So you have 2, 1, 3, 4. Multiplying 2, -1, 3, -2. So in multiplication, it is done as row against column. Row multiplying column, row multiplying column. So you are going to get this row taking this first column for the first time. So you are going to get 2 times 2 plus. So in the first row, the 2 will take the first 2 in the first column. The 1 will take 3. So you get 1 times 3. Then in order to get the other side, this same row will multiply the second column. So you are going to get 2 times -1. Then plus 1 times -2. You come to the second row. Second row takes the first column. So second row against the first column. So you get 3 times 2 plus 4 times 3. Then the second row against the second column. You are going to get 3 times -1. Then plus 4 times -2. So what are you getting? This is 4 plus 3, giving us 7. This is -2, -2, giving us -4. This is 6, 12, giving us 18. This is 3, 8, giving us -11. So this is our AB. But mind you, if they say that multiply A to B, make sure you do it according to the order given to you. Because if you come and turn it and do BA, BA is never equal to AB. Is that okay? So if they say do AB, make sure you do AB, you don't do BA. Because in matrix multiplication, it is not commutative. Okay. Another example that they can give you is when they give you A to be 2, 1, 3, 4, 1, -2. This is our A, and our B was given to be 0, 1, 1, 2, 2, 3. So this is the B and A given. Then the question said you should find AB and BA. But clearly, we can tell from the dimension that one of this is not going to work. Why? Yes, now, let's first take care of AB. Number of rows is 2. Number of columns, 3. Over here, number of rows, 3. Number of columns, 2. So this is going to is equal to this. So it means the multiplication is possible. So if the multiplication is possible, when you can write your A, 2, 1, 3, 4, 1, negative 2. Multiplying 0, 1, 1, 2, 2, 3. So this row against this column. So you are going to get 2 times 0 plus 1 times 1 plus 3 times 2. Then you are done with the first row against the first column. Then let's go to the first row against the second column. You get 2 times 1 plus 1 times 2 plus 3 times 3. You are done with the first row. Let's come to the second row. 4 times 0, 1 times 1, negative 2 plus negative 2 times 2. You are done with the second row and the first column. Then you do the last one, second row and the second column, which is 4 times 1 plus 1 times 2 plus negative 2 times 3. And this is going to give us 2 times 0 is 0. 1 times 1 is 1. 2 times 2 is 6. 6 plus 1 is 7. Come to the second one. 2, 1, 2. 2, 1, 2. 9. 9 plus 4 is 13. This is 0, 1, negative 4. So you get negative 3. This is 4, 2, 6 minus 6, 0. So this is the result for multiplying A to B. So after multiplying A to B, we ended up getting 2 by 2 matrix because the side that meet and are supposed to be equal will go away. So the resultant matrix dimension should be a 2 by 2. So remember, I wrote 2 questions. I said we are doing A, B, and B. So please try the video yourself and comment at the comment section.